Perfect. Hello, everyone. Super excited to kick off the first workshop for the EDU Chain Hackathon by Open Campus. Today, we have the HackQuest team with us. Hey, Harry. Thank you for joining us today. And yeah, like I said, we kicked off the opening session, opening ceremony of the hackathon day before yesterday, which was also super fun. We had a bunch of sponsors with us, but like I said, super excited to kick off the workshop series. Harry, without taking a lot of your time, I'll pass it on to you. Feel free to take up the stage. Feel free to elaborate on your expectations as well. Any suggestions for the devs participating in the hackathon, and definitely with the technical content that you have for us today.
Yeah, sure, absolutely. GM, everyone. Thanks so much for joining the very first workshop of EDU Chain Hackathon. We're excited to be here. So again, this is a month-long hackathon. We'll have three workshops, a lot of mentor support, sync and async to help you build your dApps on EDU Chain. So just a very quick intro. My name is Harry, co-founder of HackQuest. We are one of the partners of EDU Chain and also Web3 dev education platform. Avi, pass it on to you.
Hi, everybody. Hi, everyone. I'm Ivy. I'm the DevRel from HackQuest. We're very happy to be here, and I'm looking forward to share anything with you. I'll back
Awesome.
to you, Harry. Yeah.
Thanks, Abby. Yeah, we'll do a quick intro of HackQuest as well. So HackQuest is a free self-guided Web3 education platform. We offer expert-curated learning path with on-chain certifications co-issued by leading Web3 ecosystems, including Arbitrum, Solana, Mantle, Linea, Vera, and so forth. Our event organization arm called Moonshot Commons is also a global community for Web3 founders and developers to build and grow. And we have hosted over 30 plus Web3 hackathons and 100 plus developer events since 2021. We over 85 of our community projects founders are backed by A6 and Z, YC, and many more. So if you have any questions throughout this presentation, please send them in the chat box or comments, and then we'll try to answer some of them live. And if there are longer questions, we'll kind of refer you to the Open Campus Discord channel. And so if you can post them there, we'll have people to answer kind of more in detail, and other people can benefit from that as well. Awesome. So without further ado, today's topic is building dApps on Arbitrum Orbit, dApp tools and documentation. So we will really focus on doing an overview of a technical overview of EDU chain, Arbitrum Orbit. We'll run through a demo of how to deploy smart contracts onto EDU chain. And eventually, I know a lot of people are probably here for all the tools and resources that we would recommend. So we'll really zoom into that as well. If time permits, we'll have a Q&A session. So do put your questions in the chat box. So we'll accumulate that and pick a couple of ones that's probably going to be most helpful for everyone, and then kind of go from there. So quick recap if you missed the beginning session. So what is EDU chain? So EDU chain is the very first O3 rollup by Open Campus and on the Arbitrum Orbit stack. So it's dedicated to education applications. So EDU chain established as a very innovative learn, own, earn model. So learners will learn from its dApp partners and own verifiable credentials. There's going to be learning progresses, knowledges that eventually will help improve their earning capabilities and also job prospects. So it's a very important step where we put ownership of the learning back to hands of the learners and the educators. So then moving on to kind of the open campus ecosystem. So open campus, as you know, is a DAO community-led protocol. It's a place where educators, content creators, parents, students all convene. Currently, the ecosystem has over 80 partners, including Animoca Brands, TinyTap, New Campus, Binance, Forbes Web3, and so forth. Likewise, we're also proud to be one of the partners. So let's take a deeper look at the EDU chain, some of the layers of it. So we have learned that EDU chain is the first L3 rollup chain on the Arbitrum Orbit stack, which is what our focus today. So what does it really mean? So if we really think about the two primary features of EDU chain is OCID, Open Campus ID, and we have the publisher NFT. So at a very high level, and we'll zoom into that later on, OCID is a self-sovereign educational identity that houses verifiable credentials, academic certificates, EDU domain names, and OC points on the EDU chain. So this ID will also be a great way to verify the learner's reputation. So as you build your dApps here, these infrastructure will be the center of a lot of your activities, can really power your growth. There's another one called Publisher NFTs. It allows content creators like teachers and educators to share and monetize their content. And with this feature, EduChain not only provides educators and creators with a novel way to learn, but by linking the revenue generating products like the contents with NFTs, it also introduces the possibility for co-publishing. And then I think for the finance layer, it's pretty straightforward. I think it's really important to have liquidity provider. They provide the liquidity necessary for the development and scaling of the ecosystem. And you can consider the projects listed on the DeFi track. And aside of this, which is the focus of today, which is the chain layer, is the Arbitrum tech stack, which supports the operation of the chain. So now moving on to the bulk of the presentation, we'll start with kind of a quick introduction to Arbitrum and then zooming into Arbitrum orbits and the technology that powers the entire Arbitrum ecosystem called Arbitrum Nitro. We'll do a technical overview and then we'll follow by the demo. So the Arbitrum ecosystems really consist of the two big components. You have the two mainnets, the two live mainnets. You have Arbitrum 1, and then you have Arbitrum Nova. So they're both L2s of the Ethereum chain. They can be built with Arbitrum orbits with simple steps and are very customizable. Arbitrum 1 and Nova both have very high throughputs. Uh, what that means is you have very high, it's very fast. It has very high transition speed. It's less than 1 second transaction confirmation time. In fact, about 0.25, a fraction of a second block time to be more specific. Obviously, that's very impressive if you look at we have a speed breakdown later on. Not only that, the transaction cost is only a fraction of Ethereum L1s, up to 50 times cheaper for Arbitrum 1, and it can be 150 times cheaper than L1 on Arbitrum Nova. So Arbitrum Nova achieved that significant result, right, due to its antitrust method, where its call data is sent to the data availability committee. And that's the primary point of differentiate between kind of Nova and antitrust as well, rather than directly posted to L1. And the data availability committee is permissioned set of parties. They're responsible for enforcing data availability. They store the chain's data and provide it on demand. So for today, we will really zoom into Arbitrum orbits, which is what EDU chain is built on. So introduction to orbit chain in a more hierarchy perspective. So the orbit is very versatile. It can be used to launch an Arbitrum 1 or Nova chain as an L3 that consolidates the transactions to L2, either to Arbitrum 1, Arbitrum Nova, or other Ethereum L2 to achieve essentially cost effectiveness, scalability, and security. It can also be used to start an L2 that consolidates to Ethereum L1. If you are an Arbinaut, then I'm sure you're very familiar with Arbitrum Nitro. It was described by Arbitrum co-founder Ed Felton 2 years ago as the latest and greatest version of Arbitrum technology. It is the top to bottom rewrite of the software stack to make Arbitrum faster, simpler, and cheaper compared to before. And fast forward to 2024, 2 years later, it is now the technical stack that powers the entire Arbitrum product. So from rollup, antitrust, orbit to Stylus. And Nitro uses Go to compile code into native code for specific computational architectures, while also compiling the same code into binary WASM for fraud proofing. So it allows a lot of potential for building on top of Arbitrum. So, and a big part of today's session is about why should you build on EG chain, right? I think in the opening session and from some of the following session, I think we have given plenty of reasons on the EDU chain ecosystem side. And now let's talk about why Arbitrum orbits, like why do we specifically promote EDU chain to be on Arbitrum orbits? And then here are a couple of reasons, and we'll review it in the technical perspective as well. So Arbitrum 1 is the only universal layer 2 that advanced to the what we call the stage 1, meaning it has met the requirements in fraud-proof development, permissioned operators, and security console establishments. So Arbitrum Orbit would inherit all these properties as the orbit is built on the same tech stack. And most of the other leading blockchains, as you saw here, they are still in stage 0. So Arbitrum Orbit is very decentralized, to be short. Another is Arbitrum Orbit is very fast. So we talk about Arbitrum Orbit as one of the fastest, super fast block time. The transactions confirmed literally in split seconds, in fraction of a second. It adopts, which we'll dive into later as well, called optimistic rollup structure that allows higher throughput and also faster transaction processing. So aggregation of the transactions into a single batch and reduces the congestion and speed up the overall transaction processing time. And Arbitrum support parallel transactions processing, which greatly improves the throughput as compared to sequential processing. So if you look at Arbitrum 1, it is already extremely fast compared to others, and essentially Arbitrum orbits is even faster. It would essentially be fractions of a second. Another very important thing from a builder perspective is how much infrastructure is supporting the ecosystem. If you're a multi-chain builder, I'm sure this is very important to you to notice what infrastructure maybe you're using some of these tools and softwares to kind of power your project. So if you're expanding to a new chain, this might be something you pay special attention to. And there's some resources and tools we'll share later that also allows you to go through these more in detail. So Arbitrum Orbits is supported by many tools here. You have, XLAR, you have Layer 0, you have Across, Chainlink CCIP, Wormhole. So most of the major interoperability solutions here are available for EDU chain. So they're available for Orbit. So they're by default available for EDU chain. So let's say if your project, if you're working on, let's say the DeFi track, and if you're building a decentralized exchange, let's say, and that obviously requires extensive cross-chain operations. You may want to look into, let's say, XLAR. It supports many different chains, and you can check out there. We have some tooling there available later on that supports that discussion. And let's say if your project needs to bridge assets from to EDU chain or vice versa, you may look into Wormhole. It is a message passing protocol, right, that establishes cross-chain exchange governance and games. If your project needs some level of programmable token transfer, like cross-chain lending, Chainlink cross-chain interoperability protocol, known as CCIP, would also be a tool that you may be looking for. Another very essential part of the infrastructure side is the wallet or the AA account abstraction side. So Arbitrum Orbits is supported by wallets like MetaMask, like Coinbase, like Economy, like amongst them all. You might use Rainbow if you want to support like multiple options. Yeah, so obviously I think this is very essential to to a lot of the infrastructure builders, especially if you're building a Dapps, having these options available is super important. Another important part is oracles and indexers. So you might sometimes, if you're building a Dapps that requires data or events from the real world, then you would look into these options. So let's say you need the crypto prices. So Chainlink, right, allows you to provide the information needed. And if your project needs high frequency or low latency data, you might look into Path Network. So all of these are really good options, and they all support Arbitrum Orbit / EDU chain. So quick recap. So why Arbitrum Orbit in a summary? So one, you can tailor to specific business needs. So EDU chain is an L3 that's on top of Arbitrum. It uses Arbitrum orbits to make it cost effective. It further enhances the focus of and dedication to education. It has a dedicated throughput. You can set the transaction time to be as fast or as low as it suits your project. Another aspect is interoperability and yet independent. So you may set it as permissionless, permissioned, and anything in between based on your specific needs. So it's highly customizable that way as well. It is also pretty easy, relatively easy to develop if you're considering. And then this is probably very important to many devs who might be new to EVM ecosystem. So there's EVM plus compatibility. What that essentially means is no matter your existing projects or smart contracts are written in Solidity or other languages like Rust, like C, like C++, you will eventually be able to deploy onto the Arbitrum Orbit chain. And that's something we'll actually focus on later on for both Solidity and also non-Solidity devs. There are options to deploy to EDU chain. Although just a little bit spoiler, you might have to wait a little bit for non-Solidity devs. So let's say if you want to use Stylus, that's not live on the main on mainnet yet, so it will take some time. But right now, in a few weeks, let's say in semester 2 and 3, you will be able to deploy using other languages. You can also set your own governance protocols, so rules mechanisms that govern the decision-making process. It can also be one or Nova. So I think Arbitrum Orbits was a very obvious choice there. There's some other orbit chains that have kind of established themselves as orbit chains, and then so I think due to time, we'll now dive into that. So now we have established the basic understanding of Arbitrum ecosystem, of EDU chain, of the Arbitrum orbit as an L3 that allows EDU chain to be successful. Now let's look at what makes it very special, the technology stack that powers this entire this blockchain. So is the Arbitrum Nitro stack. So it powers all the products in the Arbitrum ecosystems. And there are pretty much 4 basic concepts as we dive deeper into how Nitro works that we'll go over. First is an optimistic rollup. That's the basic architecture. Second, it functions by doing sequencing followed by what we call deterministic execution. And then we put Geth at the core of the software, and then we separate execution from proving. So I'm going to dive a little bit more in a lot more detailed about what each of this means, but this is a high level roadmap to understand it layer by layer. So we'll start with sequencing. So everything in blockchain starts with sending a transaction to the network, so it's no exception for Arbitrum. So a sequencer will pick up the transaction here. So the systems, and this is kind of the overarching chart we want to take a look at here. So the systems here starts with a component called the sequencer. So for those of you who are not familiar with sequencer, it is the job is to take transactions submitted by users and order them in the sequence that they arrive. So it follows a first come, first serve approach. And right now, it is a centralized component run by the Option Labs team. However, the system is moving towards a more decentralized approach. Decentralized sequencer is obviously a very important field of studies right now. So the only thing trusted of the sequencer is to verify the order of the transactions, right? So coming back to what the 6 sequencer's job is, there is some mechanisms that we will skip for simplicity to bypass the sequencers if it tries to censor transactions. And once sequenced, the transactions will run through what we call a state transition function. This function is a deterministic piece of code that determines the effects of each transaction on the system state. So it takes the next transactions in the sequence and the current state as inputs, and then they produces an updated state here as the output. The state transition function can also emit layer 2 arbitrating blocks occasionally. So this section. So here's how the execution happens. So the transactions are sequenced. Sequence is then processed one by one to the state transition function. And since the state transition function is deterministic, knowing the sequence of the transactions determine the entire evolution of the system state and the resulting layer 2 blocks. So what this means really is anyone can independently execute the state transition function with a known transaction sequence on their own code, on their own node to understand the outcome of computations on the chain. And everything deterministically follows the transaction sequence. So let's come back to the core question that's remaining, right? So how do we find out the transaction sequence in this case? So the sequencer publishes a real-time feed, right, of sequence transactions that they receive. And anyone can subscribe to this feed and receive updates almost instantly. So under normal conditions, your transactions will be sequenced and appear in the feed within the second of submissions. And by believing the sequencer's feed, you can know the outcome of your transactions in less than a second. You can subscribe to the feed, take transactions, and run them through the state transition function to understand everything about the chain's current state. The sequencer periodically batches sequence transactions. They compresses them and writes them onto the mean Ethereum chain, the layer one, and this records the transaction sequence. Once this record achieves finality on the Ethereum chain, the transaction sequence becomes final as well. And everyone can then execute a state transition function with this final sequence to understand the exact state of the chain. So everyone technically has access to this process. So this is a little bit complicated in the sense, and we touched on the concept called finality. So let's briefly go over it. So there are three types of finality really that we usually consider in this system. So one is called self finality. This is achieved by subscribing to the sequencer feed and running the state transition function on all the transactions in the feed. So if the sequencer is honest, this guarantees the correctness of the results for the chain. And then we have hard finality. This is usually takes about 10 minutes here. This involves monitoring the main Ethereum chain, the L1, to compress transaction batches. And once you have a batch, you decompress it to identify the transactions, run the state transition function, and then wait for the batch to finalize on the layer one. This finality is as strong as your assumption about layer one's finality. So yeah. And then the last, piece of here is certifications, and this would take days. This is the process where the Ethereum chain learns the outcomes of computations, where anyone with the transaction sequence can determine the chain's results. The chain itself, right, like the Ethereum chain itself, lacks the computational power. Um, for real-time processing. So this is why layer two like Arbitrum exists in the first place. Since the ETH chain cannot compute alongside the chain, an alternative method is required here. So by achieving the weighting for the layer two blocks generated by the arbitration chain to be certified on layer one. So this is primarily used by layer one contracts. Yeah. So moving on to the second key concept here is Geth at the core. So Geth here refers to Go Ethereum. It's written in Golang, so it is the software that makes up the Arbitrum node and has three layers. Many call this kind of like a Geth sandwich because you have two layers and then one in between. So here's kind of the breakdown, right? So the node functionality piece, this is the layer that built on top of Arbos and allows Arbitrum nodes to act as the servers responding to users wallet requests through RPC API. So it's similar to Ethereum nodes themselves. In the middle, we have this thin layer called essentially that sits on top of Geth core. It handles L2 specific tasks like sequencer reimbursement. It handles deposits, withdrawal between L1 and L2, L2 bookkeeping, and so forth. And the core here, this is again Go ETH or Geth. It emulates the EVM or Ethereum virtual machines for transaction processing, and the gas component that tracks the gas cost and maintains the Ethereum state database. So together, this sandwich with Geth at its core allows Arbitrum to achieve high compatibility with Ethereum, and is why we can proudly have a lot of the core features that we just mentioned earlier. And then another important section is called separating execution from proving. So I'll just very quickly go through this part due to the time limits. So ordinary Go compilers here is used when compiling the source code for execution. And while compiling for proving purposes, the same source code is compiled to WebAssembly. It's a typed portable machine code formats. And all this trying to say is this method helps in mitigating malicious code. So the separation is a very important part of the system. And I'm sure many of you are very familiar with optimistic rollup. And something that we would mention is Arbitrum also follows this rollup-centric roadmap for Ethereum proposed by Vitalik. So the idea is that rollups provide a level of scalability and low cost that the Ethereum chain itself has trouble providing. And so what Vitalik was discussing before is proposing a roadmap for Ethereum where Ethereum focuses on enabling rollups. Rollups themselves, they provide the execution and storage layers for applications. And while Ethereum will focus on being the best underlying layer for rollups. For what rollups means essentially is that the data of your transactions is stored onto L1 Ethereum chain. So it is an optimistic rollup because of the way that we settle transactions back to the Ethereum chain. It is a protocol that is always guaranteed to be correct, but it's especially fast and efficient when people have behave according to the incentives. So again, Arbitrum Nitro stack uses optimistic rollup. It is one of their determining characteristics, and let's kind of take a very quick look of how it works at a high level. So at its core, Alice as the validator would claim the end blocks here as valid, and the results will be accepted if there's no challenger to the results. That's why the name is called optimistic. So what if when there's a dispute, we're in a challenge situation, then Arbitrum would use an interactive proving method. So it says that, let's say Bob disagrees to the end state that Alice kind of proposes here. Then Bob is required to post his version of the end state of the dissection of the segments, and then it says, and then Alice will then respond by identifying a subsegment and then posting on an alternative endpoint for that segment and dissecting it. So at a very high level, this is how kind of the disputes is the resolution process would work, and is to provide a tiny bit more context. It's resolved in the context of WASM code, and the code defines the correct execution of the state transition function. The beauty of this approach is in ordinary execution, the code runs natively for speed, and in disputes, which are significantly less frequent, right? So the code, because you're incentivized to behave, to answer correct. Otherwise, there's a lot of punishments involved in this situation. The code can be less performance. So in disputes, the code can be less performance, but also needs to be portable, reliable, and secure, which WASM or WebAssembly excels at. So now we have spent about 25-30 minutes covering some of the technical stack behind Arbitrum Orbit, Arbitrum Nitro, and why EDU chain is very powerful from a technical perspective to build your project. So if you're considering to launch a project and building on top of EDU chain, I think you have plenty of reasons to do so from a technical perspective as well. So now we'll move on to actually showing you a demo of deploying contracts written in Solidity to EDU chain. So I'll pass it on to our beloved DevRel Ivy to do a real-time demo here.
Finally, sorry about that, everybody. Thank you for staying tuned, and I'll now be able to put up my terminal. As Harry has already went through it, the slides with you about the process of it, I'll just quickly do the demo of how to deploy it with the Solidity contract on Orbit chain. It's pretty easy. You just like any of the. All right. Okay, just like any time you start your project, just go through any folder that you would like to do it. Usually I'll just do it on my projects folder. So that's where I'm going to start my projects. First, just use, okay, before I go into this, let me just mention a little bit like the tools that I'm going to use. I'm going to use the Foundry, which is one of the development environment that I'm going to use to develop to start to deploy this projects. So this is going to be the command line that I'm going to use, which is starting with the Forge. I'm going to share it with you, the documentations available later. So to start with, you use Forge build, and then you give your project a name. I'm going to call it edu chain for now. So after that, you have create your project, and it just started, so it's nothing to compile. You can go into your project folder. Oh, did I go there? Oh, sorry. Let's do that again. We go into the project file. I missed one step, no wonder. So the first step you're gonna do is always like many project where you start with Forge init. The project name is EduChain. Yep, now it's starting. And well, if you want to check the if I really have started a project, you can just this is what you can use. Forge build. It will check if your project is all right. So it's actually nothing to compile now, but the project is there. So then you go to the project folder you have just created. Now at this project that you have created, then you need to install the dependency needed, and where you need to go with this Forge install. What we're going to install is this OpenZeppelin library, which is very common, used by the Solidity community, because the standard is so there. So this is what you're going to have. No worry, just now Harry have already shown you what is the command line is like, and then we're going to give you this document where is also have all this available. All right, now is installing all the dependency. All right, I think I know what's the problem. I have been locked up from my GitHub. Let me try to log back in. So for this one, it's going to done with installing the OpenZeppelin into the project. So after that, what you're going to do is going to the Visual Basic Code. I just take it that we have been able to install this dependency. Let me just get off this and show you with the Visual Basic. All right, let me just bring up another screen. All right, so let me see. Can you see my share screen? Okay, it coming up. All right, here. Now, just now I have like create a project. I have already have a project that is ready before that. Let me just go to that project instead. Now, take for example, this is the project that we have created just now. You go to open it with your Visual Basic and you go to the source, and then you'll see here with the contract that you have. What you need to do is just to go to the project file if you have already create and write your code with Visual Basic or any other editing tools that you like. Go to copy your code. And paste it here. I'm just going to use the default one. All right. Let me just bring back the terminal. So let me just go to the project that I have previously done. So after that, like, you have get all your contracts ready in the source file. What you need to do is to go and start getting this command ready to post it to the net. Oops, let me just check. Okay, what you need to do is use the forge and create. This is the command that you use to create to deploy the contract. And then you need to have the right contract name, which is, I did it wrong here. If I go back to the code, it is the forge create NFT. Nope, nope, nope. Let me just go and check what is the issue here.
Ivy, I think we're a little bit running out of time, so I'm thinking maybe instead of walking through this full demo, because I think you're just logging out of GitHub, If you want to go back to screen presenting and then finish up the rest of the presentation, what we can do is to send the demo recordings, which we have done in a group later on, to across socials and also just to all the builders who might need the support. What do you think?
Sure. Thanks, no problem. And by the way, that is in together with the doc, or we will just put in the link for the presentations that we have recorded before that. And yeah, once you have got all these things done, you will get this result, which is you'll be able to go through it. Let me just show you that, like, how it is going to be like with this. Would you be able to see my share screen now? Yep. All right. So let me check. Okay, cool. You can see my share screen. Now, I'm just going to briefly go through it with you that, like, if you are going to deploy it into any other contracts, you will be able to. Now, if you are going to use the Arbitrum Stylus to deploy any other contract that written in any other language, for example, Rust, C, or C++ to the Orbit chain, like Harry have said just now earlier on that, like, it might not be ready now, but it could be ready in the next few weeks or anytime soon. I'm just going to bring you to this a little bit that, like, when you want to use Stylus, first you need to install the Stylus CLI tools. And then later on, you need to rest up the WebAssembly. And this is the, oh yeah, right. I have gone. This is the GitHub from the office off-chain labs, because as if you want to use any other language to deploy a contract, there is this codes or contracts that, like, you need to have in order for your non-solidity contract to be able to match with the API of this solidity standards. So what you need to get, there will be a file there. So if you go ahead this link, which will be given to you, and download the code available inside there, that is already a sample code that you can use, so you don't have to write that yourself. And all you need to do is, in that whole folder, go to the source, where is the folder lib.rs, and you just paste the code that you have written into that folder, and then go to terminal, add the folder of your project. You check first if the project is valid by using couple stylers, check. And if everything is okay, then you can go to cargo stylers deploy with the RPC path, which we will be ready in the doc as well, and with your private key. And this is a sample that we deploy in the Arbitrum Spolia, but then the rest will be ready soon. Now, there is a lot of other tools that you can use in order to help you to deploy this your projects on the chain. First, we will have this Open Campus Explorer, which allowed you, like, for example, just now you have seen that, after the contract has been deployed, there is this transaction hash. if you just use this transactions hash to go through this Explorer, you'll be able to check the details of the contract and to make sure that it is properly deployed. And in order to get this test EDU, which you needed to deploy your projects, the fee is really minimal, but you still do need this to make it happen. You do need to kind of mine this token, which you do not actually need any mining power. It's just running of the time for you to get this token. It's just to help mitigate people exploiting the tokens. And then if you do need this other tools, for example, you can use Explorer for interoperability as well. All the links are available. Then if you would like to know more about you need to know more about EduChain as well. That will be a good documentation for you to go through as the EduChain documentations. And you can check it at this the Stylus SDK and then the Stylus document. And this is the link for download of the ERC20 sample. Yep. And just now, the Foundry that I was talking about is a good tool for you to develop your contract as well as for you to test your contract or even quickly launch nodes to test your contract. Right. So this we'll have three upcoming. The upcoming one is done, which is today, and there'll be another two workshops that's going to help you with your projects. And please join the Discord for the round-the-clock support, and you may also sign up for one-to-one office hour, and do connect with the fellow Dapps in the Dapp chat as well as the Dapp forum channels. Harry, I'm just gonna pass it back to you. Let me just stop sharing.
Sure. Awesome. So we're near the end of the presentation. So I think the last thing I want to touch on, in addition to what Ivy already mentioned, is the contact information. So again, to quickly recap, we already finished the tech onboarding session today. I think Ivy very soon will post the links to the two demo for Solidity and Solidity recordings. So if you are interested in trying it out before you actually submit your project, you can deploy onto EDU chain that way. And then after this onboarding session, we have two more workshops. So one is integrating backend with frontend. So it will be presented by Ankit from Ryzen. And then we have a tech clinic session. So are led by Arbitrum Foundation will most likely join that session as well. And where any type of Q&A questions or more personalized questions about your projects, feel free to ask in that public, essentially office hour. If you have any specific questions, tailored to your project, or let's say if you want very specific instructions on a particular step, let's say you don't know how to deploy one of the contracts or have difficulties getting, let's say, EDU tokens through the faucets, then join the Discord. Actually, you should join the Discord regardless of whether you have questions or not, and then just to sync with fellow devs. And a very special part of this hackathons, we actually have one-to-one office hours we have 10 leading hackathon mentors who have hosted hackathons like ETH Denver, like ETH Chicago, like Web3 ETL, like Nitro and Token 2049, like ETH Shanghai, and so forth. So a lot of these mentors, they will guide you through one-to-one personally. So you can sign up for 10, 15, up to 20 minutes of their time, and then really give you personalized feedback for your project. So definitely check it out. Some of them may even have Calendly, so if you want to schedule longer time, you can request that from them, and then they will help you out. So personalized feedback, Discord, post on your forum, so all your questions get answered, and other people can benefit from that as well. And if you have any particular questions, feel free to contact us. I think I put Open Campus and Hack Classes info here. Join the Discord, join the Telegram. If you have specific information about this presentation or this or just deploying to building on top of EDU chain in general, feel free to email us or send us a message in the Telegram or Discord group. If you have specific questions for me or Ivy, feel free to just look us up on Twitter. Mine is Harry Zhang S, and then Ivy is Ivy Fong 1. So I think you can. And those were, if you follow Open Campus, you will see our handles there as well. So thank you so much all for joining this workshop. Sorry about the technical difficulties, but we'll send the recording links over soon. And definitely sign up for mentorship and one-to-one office hours if you have specific questions. Ashika, I'll pass it back to you.
Thanks a lot, Harry and Ivy. I really appreciate the time that you guys have taken. We don't have a lot of questions, but we do have some comments about the docs. Gopal asked about how can we get the docs. Gopal, the docs are there in the chat section. However, if you miss it, you can always go to the hackathon page on DoraHacks, click on the details tab, and just scroll down where you will find the developer resources, and that is your go-to place for all the docs, and like more. There's also the Discord link, the website for the for the different partners we'll be working with during the course of the hackathon, etc. Then another one is I would love to talk to you about building with Stylus and deploying on EDU chain. Like Harry said, the office hours would be the best place to connect with mentors one-on-one. So yeah, probably also join the Discord to meet some devs, to just throw in your ideas, to get some kudos by the mentors. And yeah, all in all, like, do join the Discord, put on your hacker caps. We have another workshop on 24th of July at the same time. The good thing about the workshops is they do have significant time in between, so you really have the time to grasp all the information shared during these workshops. And then workshop 3 would be on July 31st, again at the same time, which is an office hours FAQ kind of format. But yeah, again, a very good luck to all the hackers and builders building in this hackathon. Feel free to reach out to DoraHacks in case of any any query you have on submitting on the platform, any other details that you want, so we can connect you with the right folks. But really, Discord should be your place. Feel free to also reach out to Harry, Ivy, or anyone from the team.
Thank you all.
Yeah, thank you, everybody. Happy hacking.
Thank you, everybody. Take care. Thanks for joining.